I'm going to be talking about forms of linear equations. For any given linear equation, there are several different forms that we can write it in. First is the familiar form that we've already been through. If we write it like y equals mx plus b, this is called the slope-intercept form. Now the reason for this is that m here is the slope of the equation, and b is the y-intercept. We already saw why m is the slope previously. To see why b must be the y-intercept, simply plug in 0 for x. Then n times 0 will be 0 and y is equal to b. So the point 0, comma b is going to be the y-intercept. So if you know in advance, say someone told you the slope of this line I'm thinking of is 2 and the y-intercept is 7, then we know y is equal to 2x plus 7. This is usually the most useful form that you can write a linear equation in, but sometimes you're not going to know what the slope and y-intercept are, and there are other forms to accommodate for those situations. The next form we're going to talk about is point-slope form. Suppose that we know in advance what the slope is, and we also have a point x1, y1 that's on our line. And now we want to write an equation to represent this entire line, given these three pieces of information, m, x1, and y1. So we know that the equation for the slope is m is equal to y2 minus y1 over x2 minus x1, if x1, y1, and x2, y2 are 2 points on this line. This is the same as saying delta y over delta x. But since this equation holds for any points x1, y1, and x2, y2, let's say that the first point is the x1, y1 we're given, and x2 and y2 are just x and y. Then we have m is equal to y minus y1 divided by x minus x1. Now we can multiply both sides of this equation by x minus x1 to get m times x minus x1 is equal to y minus y1. If we rewrite it as y minus y1 equals m times x minus x1, we now have the point-slope form of the equation. Now, what if we're given 2 points, x1, y1, and x2, y2? How can we write an equation for a line in this situation? Well, first we can use the equation for a slope. M is equal to y2 minus y1 over x2 minus x1. Since we already know what y1, y2, x1, and x2 are, we can calculate this. So now we have m, and we also have a point, x1, y1. So we can just use the point-slope form. Another interesting form we can write linear equations in is called standard form. Standard form looks like ax plus by is equal to c. Here we require that not both a and b are 0, so a and b can't both be 0, and a is greater than or equal to 0. So if we had an equation y is equal to 2x plus 2, how could we put this in standard form? Since we want x and y to be on the same side of the equation, let's subtract 2x from both sides of this. Then we have minus 2x plus y is equal to 2. But notice that the x coefficient here, minus 2, is less than 0, which is not allowed. So we can multiply everything by minus 1 and get 2x minus y equals minus 2, which is the standard form of this equation.